So, first of all, today we will be starting with the haloalkanes chapter. The haloalkanes and haloarenes. So, to test haloarenes and haloalkanes or distinction between pairs of organic compounds containing halogens, we need is the AgNO3 solution test. Okay, so first of all, what we need to do is that the halide is warmed with aqueous alcoholic KOH, and then the solution is acidified, acid catalyzed with dilute HNO3, and then again the solution is passed through HNO3, and then we will get the product. Now, alkyl, benzyl, and allyl gives the precipitate. That means it follows through it gives a reaction. And then aryl, vinyl do not give the reaction. And it may be noted that the precipitate formed should be insoluble in HNO3. Yeah, it should be insoluble in HNO3 because we have some enemy reactions here, that is something like ethyl chloride plus HNO3 gives HCl, okay, and ethyl bromide plus HNO3 gives HBr. Okay, so this is white and this is yellow, as you know. So that's for the haloalkanes part. Now we come to the alcohol, phenol, and ether chapter. So the test will be first the Lucas test. What are the reagents? The alcohol will be treated with Lucas reagent. Is an equimolar mixture of HCl and ZnCl2. The alcohols are soluble in Lucas reagent and form a clear solution. On reaction, alkyl chlorides are formed, which being insoluble result in turbidity in the solution. So the reaction will be like HCl and ZnCl2, that will be alkyl chloride plus H2O. So we must remember that the thing is, if turbidity appears immediately, tertiary alcohol is indicated. If turbidity comes within 5 minutes, secondary alcohol is indicated. If turbidity doesn't appear or it forms after heating the solution, primary alcohol is indicated. So 1 degree no turbidity, 2 degree after 5 minutes, 3 degree immediate. Okay. Now let's go to the second test. Our second test will be the iodoform retest. What is the iodoform test? When ethyl alcohol or any alcohol containing group that will be heated with iodine and aqueous NaOH or Na2CO3 solution at 333 to 343 Kelvin, a yellow precipitate of the iodoform is obtained. So let's see the reaction now. First of all, iodoform test is done in this kind of groups. Okay, we need this kind of groups here. Here will be a CS3 and here will be a CS3. This kind of groups are needed. Okay, the 2 degrees can be seen here. Okay, so let's do the reaction now. First of all, we will try to go to what channel? Okay, so let's go to this kind of ethanol. Let's do ethanol. So we can see that ethanol plus 4I2 plus 6NaOH heated gives what kind of reaction? Iodoform. It gives iodoform, which is settled down, will precipitate. You should remember that. Plus HCOONA plus 5NaI plus 5H2O. This is the reaction. We all should remember this. What about methanol? Methanol won't give the reaction. Why? Because it is just CS3OH. It doesn't have this one. Methanol, it is this, and this is the H. So the 2 degrees can be seen. Okay, so that's why it is working. Let's go 2 degrees or 3 degrees. Will 2 degrees give the reaction? Yes, of course, but 3 degrees, no, it won't give the reaction because let's see what happens here, okay? So, about 2 degrees, we are must be talking about, let's say it is pentan to all, okay? Pentan to all is drawn in this way. How which way? Guys, tell me. Okay, it is drawn in this way. It is pentan to all plus 4I to just repeat what I have written above. First NaOH. And then heat it, you would get the foam test. Oh my god! And then, what do you do? What do you do? What do you do? Tell me what you will write here. Tell me. Just to be safe, first of all, you guys can write this 5NaI plus 5S2O. But about this part, let me tell you from this part. Okay, so it will be R dash OH and then a R. So this is the R part and this is the R dash part. So from pentan to O, let's check here. C, 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 O. This C part broke into here. And now this part, this NaOH, this part will grow here. Okay, this breaking part and it forms CCCCONA. Okay, now you guys can understand this is how it works. Fine. Now coming to pentan 3-ol. Will pentan 3-ol give this test? Huh? Will pentan 3-ol give this test? No, it won't give the test. Can you tell me, guys, why? This is your homework. Please tell me why pentan 3-ol doesn't give the test. Okay, so timer, I will tell you why now. Because it is having R dash OH R dash group. As you can see, there is no CS3 group here. No CS3 group. It is all ethyl and ethyl. R dash. It is bigger. So this reaction won't work. Okay, so last test of the day, that is the ferric chloride test. Okay, fine, let's do the ferric chloride test. FeCl3 test, it is also known as FeCl3 or ferric chloride for phenols. It gives a violet colored water soluble complex with ferric chloride. Let's do the test with phenol. That is 6 plus FeCl 3 at what temperature? 373 Kelvin. It will give what? Fe complex. Fe complex. It will give an Fe complex solution. It will be a Fe complex solution plus 3 HCl. Remember, all compounds containing enolic group, you need to understand this, must contain enolic group to respond to this test. However, the colors of the complex are different, such as green, blue, violet, and depend upon the structure of the solution. This is violet. Okay, it is water soluble, remember that. What is the enolic group? From here we can say that this is the enolic group. Okay, this is the enolic group. You need this one to form this, react with this. Okay, you need to react with this, you need this one. Fine. C and C. This is the ferric chloride test. Thanks for the alcohol phenol in the chapter. Another question for the great distinction between phenols and alcohols is that you can do the bromine water test. What is the bromine water test? It is 3Br2 in CS2. It is 3Br2. No, sorry, it is 3Br2 in aqueous solution. What I told earlier was Br2 in CH2 that does a electrophilic substitution reaction, adds a Br in the workplaces ortho and para, but this one bromine water, it adds in the both the ortho positions and in the para positions. Okay, you can do the bromine water test. All right, let's, we also can write this bromine water test. It also came in the BT1 exam. The bromine water test, that is Br2 aqueous, 3Br2. Alright, let's go. Now the next chapter is aldehyde ketone. Aldehyde ketone chapter. Aldehyde ketone and carboxylic acid. It is the carboxylic acid test. The most famous and the most repeated test. This is the 2,4 DNP test. What it is? It is the 2,4 dry nitrophenyl hydrazine test. This is the most famous test. We all should remember it, and has been repeated in many ways. The chemical reactions of this nitroamine group with the aldehyde and ketone forming ammonia, hydrazine, phenylhydrazine, 2,4 DNP, hydroxylamine, semicarbazide amine. Okay, the skips waste, the semicarbazone, the oximes, the phenylhydrazone, the imines. You should all remember it. We should do the questions on this. It is very important for this chapter. So what does it happen here? Both aldehyde and ketones contain carbonyl group, hence they react with the 2,4 DNP test to form yellow or orange precipitate of this hydrazone. Okay, so who gives this test? Only aldehydes and ketones. Remember that. Only aldehydes and ketones. That's it. Alright, so how does the reactions go on? So we need this kind of things to happen here. There can be an R or H. So plus 2,4 DNP. What is 2,4 DNP? The 2,4 DNP is like this. Then like this. N2. See, 2,4 dinitrophenyl, and after adding these two, here is the edge. After the addition, It gives us this kind of things. Here becomes the hydrazone, the aura of this chapter. So after this gives a yellow or orange precipitate. We should all remember that. Yellow and orange precipitate. What is this also known as? This is known as the Brady's reagent. Okay, so the Brady's reagent. Next is another famous for the practicals and all is the Tollens test. The Tollens test is given by aldehydes when it is heated with the ammonical silver nitrate solution. They form silver mirror on the inner side of the test tube. Ketones do not respond to this test. Remember that. Do not respond to ketones. Ketones hate this test. Tollens reagent ketones. Ketones hate this test. Only given by aldehydes. Okay. Ketones hate this. We need this kind of groups here. Okay, this kind of groups are needed here. So what does it do? RCHO plus 2AgNH3 2 whole plus 3OH gives what? It is these groups come here. It is RCO minus plus this breaks down here comes here. 2Ag goes down, then what happens? This OH reacts here. Okay, and then what does it gives back? It gives back 2H2O, and at the end this one comes here plus 4Na3. That's how this reaction works. All right, that's how this reaction works. Now the third test, Fehling's test. It is one of the most important, most important, and many times it has been asked. It is the aliphatic aldehyde test, not given by aromatics. Only aliphatic aldehydes, when warmed with few drops of Fehling solution, give a reddish brown precipitate. What was this? This was silver color. This is a silver mirror. Okay, when you see the test tubes, the inner lining here, this inner lining will be colored. Okay, when you give the test in the test tubes. Now the Fehling's test is given by aliphatics only. This is aromatic, this is aliphatic, this is aromatic, aliphatic, anything works, anything, but this only aliphatic. Whatever the last chapter here we see that this is also for the alphatics only. This one alphatics only, but this is aromatics. Okay, all right, so let's come here now. It is the aliphatic aldehydes only. So what's the case with the aliphatic aldehydes? Let's see the reactions here. See, remember Tolan requires this silver man. Tolan loves silver. He loves silver things. But Fehling, remember, if it is an Fe, do the Cu. Okay, let's do the Cu plus 2Cu2 plus 5OH minus. This is the Fehling solution. And what happens here, you all know that, this and this becomes this, like this one and this one became that, this one and this one becomes what? It becomes RCOO minus plus. What happens then? This U also takes some of the O from here and O from here and becomes Cu2O plus 3H2O. Oh my god. Okay, you can understand. This is what this is. Reddish brown precipitate. The reddish brown precipitate. Okay, all right. Though now the last test for this ketone and aldehyde chapter, we already did this. Can you guess what it is? Pause and comment. So the last test is the same test we did just right here. It is the iodoform test. What did I tell you about this? It needs this R and R. We need that. Okay, the same thing is being done here. All right, so now we will show that how this expands and gives the next reaction. Come on, do you know about the reagent for the Finkelstein reaction, the diacetone 1 Finkelstein halorines chapter where Rx plus Finkelstein NaI in diacetone gives Ri plus Rx. Do you remember that? NaX. Do you remember that? Let's do that thing here. It is the iodoform test. So let's do the iodoform test. So what is the test all about? Let's see what happens here. It is the RCHO group. So R triple bond CS3. We need the CS3. Always remember, we need the CS3 in NaOI 3. So where do we get this? Where I told you about the Finkelstein reaction, NaI and diacetone. So let's do that thing here. So 2 NaOH plus I2 gives what? It is NaOI plus NaI plus H2O. How to remember this? Just two I's are here, distribute them. 2 NAs and 2 I's are there, just distribute them. 1 I here, it becomes NaOI. Another 2 is there, so another NaI. And so what about, you will say that, sir, what about the OH that is left now? Now 1 O given with here, so 2 are there, 2 O's are there, just give another water, just make another water. So what happens after this? Let's do it the right thing, minus NaOH, so it becomes RCOCl. Remember that, RCOCl3. It is the highest form of, sorry, it is no Cl is there, sorry guys, it is I3. See, I reaction is I, it is Ci3. I'm totally sorry about that. Okay, I'm totally sorry about this. It is RCI. Then again you flow through NaOH, and then you get what? Tell me, what does NaOH give? Have you studied the aldehyde ketone chapter? The reaction with the metals. Did you study that? Huh? Did you study the chapter? It gives what? It gives, let me tell you, it gives the Na thing. Yeah. Plus CHI3. The iodoform, the yellow precipitate I talked about. Remember that? The yellow precipitate. Yes, it is the yellow precipitate I was talking about. Let's go. This is the end of the chapter for aldehyde ketones. Now we go back to carboxylic acid. So now we will do the carboxylic acid test. First of all, the first test is the litmus test. Okay, so let us talk about this for time being now. An aqueous solution of the carboxylic acid turns the blue litmus red. Okay, blue litmus red means it is acid. Phenols also give this taste. Alcohols do not respond to this test. Remember that. Alcohols do not respond to this test. Litmus is only for phenol and carboxylic acid. Why? Intermolecular hydrogen bonding, also resonance stabilized. Okay, remember that. Alcohol, it is not, it is unstable. So blue to red, it is either CWH or it is phenol. Remember that, phenol. Next is the sodium bicarbonate test. When a carboxylic acid is added to an aqueous solution of sodium bicarbonate, brisk effervescence of CO2 is evolved. So what is that thing? COH plus Na Have you read in class 10 and class 11 about the first chapter where we did this sodium bicarbonate? We add the NaHCO3 and there is a brisk effervescence. Yeah, this CO2 gets out at the brisk effervescence, and the reactions of metals are COH, double bond and single bond OH is there, and this NaOH, the Na part breaks down and gets added to this part, and the remaining becomes this. It is the sodium bicarbonate test. It is the carboxylic acid test only. Okay, let's go to the ester formation. About the ester formation, have you guys read about the ester formations? Tell me guys about how many ways can you form esters. The first one is the carboxylic acid plus primary alcohol acid catalyzed gives RC2R plus H2O. That's the first one we are doing right here, the ester test, because carboxylic acid is able to form ester. What is the second? The second one is the acid anhydride test. Okay, he also gives this ester test plus ROH gives the ester plus another carboxylic acid. Remember that it is an exception. What are the exceptions have you studied about in this chapter? You studied about the Rayner-Timmer reaction. The Rayner-Timmer reaction, it gives what? It gives, sorry about that, it doesn't give anything. We are talking about the Coolbees reaction. Okay, the Coolbees. When Coolbees phenol is treated with what? Tell me, it is treated with what? CO2, 4 to 7 atmospheric pressure, NaOH. And after that, what happens? It produces salicylic acid, right? Plus acid anhydride produces was 2 acetoxy. Yeah, that thing, 2 acetoxy salicylic acid. Yeah, plus what does it produce? It produces acetone. Yeah, that's an exception. The acetone is an exception. It produces acetone. Similarly, also when you convert cumin to phenol, what do you produce? You produce acetone too, right? I am so sorry about that. Just forget it. Cumin, when produces phenol, it produces acetone. But the before part about the Colby's reaction, it produces 2 acetoxy benzoic acid along with carboxylic acid. Yeah, that's the methanoic acid. I'm so sorry about that. Please forgive me. It is the aspirin plus methanoic acid. So let's conclude about that. Yeah, so about the esterification we were talking about, the first one is the carboxylic acid, second is the acid anhydride, and what is the last one? It is the acyl chloride one. RCOCl plus ROH gives RCOR plus HCl. So let's write our reaction here of esterification test. It is RCOH plus ROH in acid catalyzed, that gives RCOOR plus H2O. So that's the reaction we are talking about. Alright. So this one is an ester, gives a fruity smell. Okay, yeah, and you also know that phenols and alcohols do not give this test, remember that. Next is the ester formation test. We did that. Now is the distinction between two types of acid, the formic acid and the acetic acid. So what is a formic acid? Comment in down below, pause this video. Nice guys, it is the formic acid is HCOOH. Yeah, you are right. Let's do the thing now to distinguish between HCOOH. Is a special question, the acetic acid is CS3COOH. Yeah, so methanoic acid, and I thought that is formic acid. Where is formic acid found? We all know that it's in the antibiotics, right? So let's do. So the formic acid, as we can see, which one will it keep? Which one? Which one? None. We have to see the structure. How is the structure of this? Can you see something here? Exactly. It is the RCHO type. RCHO, the Tolan one. Tolan always wants RCHO. Do you remember that? 2,4 DNP needs what? A double bond C. But Tolan, he needs RCHO, and Ferling, he needs the aliphatic one. Okay, you need to remember that. So what it will give? It will give Tolan. What was Tolan? I just now taught. What was Tolan? It is the 2 AgNH3 whole twice plus. Plus what? It is the 2 or 3 OH. Let's go with 2 OH. 2 OH gives. We have a Ag, so it will give 2 Ag. We have NH3, so it will give 4 NH3. We have what? This thing, and this thing. These both of them will go together and form what? 2 O's are there plus CO2, and at the end plus 2 H2O. Now this one, who can say about this one? Tell me. The iodoform test, or there is a special test for this one. This one is the Tolan, and another is the HgCl2 test. So it is a special question. You must have to remember this. This Cl2 gives Ag2 Cl2 plus 2 HCl plus CO2. Yeah, drops down, goes up. Mercurous chloride. This is mercurous. MERCUROUS chloride. White precipitate, guys. White precipitate. That's all for this chapter. Meet you on amines. Let's go to amines. The first test is one of the most famous. It is also there in where? CBSE sample question paper 2025 and 26. This is there, okay? The Heisenberg test. You remember this? The Heisenberg test. Heisenberg. See guys, this is CBSE sample question paper 25-26. Let's go here where you can see this amines chapter having benzyl sulfonyl chloride. Okay, remember this. Let's do the question here now. So what about this? It is the Hinsberg's test. So what happens, sir? In this test, the amine is first treated with Hinsberg reagent, benzene sulfonyl chloride, and then shaken with aqueous KOH solution. When the three amines behave in different ways. Yeah, so it has three different tests. Let's do for 1 degree, 2 degree, 3 degree. First of all, what is the reagent look like? So reagent looks like this, something like this. Benzene sulfonyl chloride. Okay, chloride. So 1 degree will do what? It reacts with the reagent. Okay, it reacts with the reagent, Hinsberg reagent. Then it also soluble in KOH. Yeah, do you know that it is soluble in KOH? And then it makes what? A potassium salt. Alright, it makes a potassium salt. This also works with it, but do you know what? If added with KOH, insoluble. It is totally insoluble. And 3 degree, it doesn't even work with this one. Yeah, it doesn't even work with Heisenberg. We could see same kind of reaction in what chapter? Tell me now, and I'll comment down below. What is it? It is what chapter? Tell me. It is the alcohol phenol chapter I taught you just now. See this. 1 degree, 2 degree, same kind of things. 1 degree does nothing. 2 degree, okay. 3 degree, yeah, let's go. This kind of shit is going on in here. See, just the opposite. Yeah, just the opposite. Remember those two things. Amines one and alcohol's part. Just the opposite. Okay. Let's go. The second will is the most important. The carbolamine reaction. It is in the PYQ book. The carbolamine. Okay, the isocyanide test. Primary amines, aliphatic as well as aromatic, react with chloroform in presence of alcoholic KOH to form foul-smelling carbolamine. So how does the reaction go? It is RNH2 plus CHCl3 plus 3KOH alcoholic gives RNC plus 3 KCl plus 3H2O. Same goes for ArNH2 aromatic. Okay, now tell me, this is alkyl isocyanate, right? Tell me which reagent in the haloalkanes part does this react with to give the same thing? It is absolutely right, AgCN. Now comment down below why. Let's do a throwback to our NCRT chapter. See, haloalkanes react with casein to form alkyl cyanide as a main product, while AgCN forms isocyanate as cheap products. Explain. So, casein is predominantly ionic and provides cyanide ions in solution, although both carbon and nitrogen are positioned to donate electron pairs. The attack takes place when mainly through the carbon atom and not through the hydrogen atom, since AC bond is more stable and the CN bond. However, AgCN is mainly covalent in nature, and nitrogen is free to donate electron pair, forming isocyanate as the main product. Remember this, okay? Example 6.5. Remember this. Let's go back here. Now, who gives this test? Only 1 degree aromatic or alkyl groups give this test. 2 degree slash 3 degree aromatic or aliphatic don't give this. Okay, it doesn't give this test. All right, next is the azodide test. You know that benzoazonium salts you heard in must be also in the haloalkanes chapter. If you read exam idea book, they have given this haloalkanes part, benzene, azonium salts, diazonium salts. It just adds, NaNO2, yeah, and then makes this N2Cl. So what is this all about? You know the reaction. What is the temperature? Comment down below what's the temperature. Yeah, this is almost around 0 degrees Celsius. 273 to 278 Kelvin. It gives what? N2Cl plus 2H2O. Now, this thing plus, do you know about naphthalene? Yeah, that structure, naphthalene. Just add this right here. All right, this 2 naphthalene. This is 2 naphthanol. Sorry, 2 naphthanol, and this is benzene diazonium chloride. At what temperature and what? Dilute NaOH, but at pH 9 to 10. Very, very, very basic. So what does it make? I just now taught you about the 2,4 DNP test, about how the chemical reactions of amines occur with the aldehydes and ketones. Same thing is happening here. All right. So that's all. And yeah, aliphatic primary amines under these conditions give a brisk revolution of into gas with the formation of primary alcohols. You can know say that about the Guttermann's and the Sandmeyer's reaction that gives this kind of diazole test too. Yeah. So let's do this once more. So RNH2 plus HNO2 at this 0 to 5 degrees Celsius gives ROH plus N2. That is a lukewarm water reaction also. Yeah, you add diazonium salts plus lukewarm water, it will give the same ROH and N2OH2 plus. Same goes for aromatics also, it gives phenol. Okay, so that's all for this 3 pages, and our syllabus is complete for distinction between things. Thank you.